lesson we're going to be talking about histograms. Here's some information about them that you can fill in your notes. The first point is that it's used for quantitative variables, and that means numbers. So in the part where you have that little space here, quantitative variables, if you don't remember what that is, that's numbers. So qualitative would be categories, quantitative involves numbers. So we would never use histograms for something like eye color. That'd be a categorical variable. So we'd use it for number of siblings in your house. That's a quantitative variable. The other part is it's used to display large sets of data. If we had a really small set of data, we wouldn't use a histogram. We're trying to use it to combine many, many numbers. And we need to choose the appropriate scale and scale evenly. Meaning, when I do a scale, like if I start 0, I can't say this is 10 and then this is going to be 40. I can't go by different intervals. My intervals have to be consistent on each axis so that I'm not skewing my data somehow or making an invalid histogram. And then the last thing about a histogram is if a number lands on the bar, it should go to the bar above. So if it's on the lines between, if you can't remember what a histogram looks like, they are connected. So if a number lands right here, it goes to the bar between. So it'd go to this one right here. And we'll deal with that when we get to it. A few more things. When we're looking at histograms, we're going to list outliers, center, spread, shape, and peaks. The outlier is a data point that is way different than the rest. To find an outlier, we look at it being as 1.5 IQRs below Q1 or above Q3. For right now, since we haven't learned about Q1 or Q3 yet, we're just going to kind of look at outliers and guess where they are, but that's not what we're going to do the whole chapter. So until we talk about those formally, we're going to kind of guess outliers. But the rule is right here. So if you happen to remember that rule from doing this before, feel free to apply it. But we will study that when we study our 5-number summary. The center is the median, which is the middle number, not to be confused with mean, which is the average, or mode, which is the number that occurs most often. So it's our number in the middle. The spread is our minimum to maximum, and we ignore outliers. So if we find an outlier, we do not count that as part of our spread. And our shape is skewed left, which means the trail goes to the left. That example of that would be something like this. Skewed to the right, where the tail goes to the right, something like that. Or symmetric, which is that bell-shaped curve you've seen before. And then the peak is where the highest bar is. We'll also eventually be talking about unimodal or bimodal. Those kind of terms will come in with histograms also, and we study them a little bit more. So when you look at these histograms, which these are really bar graphs because the bars aren't connected. Technically these two are bar graphs. We won't call them histograms. Let's pretend. We're just showing some skewness. So the histograms are, this is a histogram because the bars are connected. But we're just using this to show skewness. So let's kind of imagine that they're connected. If you look at these, if I wanted to trace my shape, I would trace over the bars like this. And so hopefully you can tell from that my first graph here, we would consider that right skewed or skewed right. It can be shown both ways because that data, that tail, is going to the right here. This one here you hopefully can see is left skewed or skewed left, however you want to say it. And then this last graph here is very much a bell curve. In fact, it's a perfect bell curve. Most of them will not be this perfect. They can have a tiny bit of skewness to still be called symmetrical. But this one is very symmetrical. You can't get any better than this, really. So there's our 3 different types of graphs, and we decide if they're skewed. So our left and right skewed are skewed. Our last graph here is symmetrical, so not skewed. Then we have just a picture here, and they're asking what's wrong with this. You'll see that they have, it's just a pictograph, really, because they're representing time in the newspapers with that pen, or whatever that you want to call that, an ink pen. And so you can see that what's wrong with this is they're making time, look at the numbers here, 1.5 million, 2.6 million, and 4.4 million. I think because they're elongating and doing a width wider, they're making these bars wider, right? Showing those bars, that pen as a wider, is making us think time is way better than Newsweek, which it is. I mean, you can see that, but with a histogram, we have to make sure that our bars are equal width and equal height, that making the intervals go the same. And so for this diagram, I would say the pens grow in both width and height, and that distorts the graph. They should only grow in height. So pens, because they're asking what's wrong with it, grow in width and height, we would say that this distorts the graph, so makes it look like it's more than it is. And to correct this, if they asked us that, the graph should only grow in height. We never change the width. Okay, and now we're going to actually apply some of this stuff to a histogram. So you can see here we have a histogram that has tuition and fees on the bottom and then Michigan colleges on the top. So the number of colleges that fit that tuition and fee. So you can see most of them are between $0 and $2,000, and then they kind of move. So we're looking for some outliers, and that would be anything that kind of sticks out as not fitting this graph. And so when I look for my outliers, when I look for my outliers, I'm not seeing anything. Like if I had all of a sudden a 50,000 over here, and there was one, I could argue that that looks like an outlier. I don't have anything that's looking like that, so I'm going to say that I don't see any outliers in this graph. And then when we look for the center, I'm going to try and figure out how many are in each bar here, and we are estimating a bit here if we're not told. So each bar, like the 0 to 2,000, I think this looks like there's 27. I'm just estimating here, right? Right here I'm going to say that looks like 11. This looks like 5. This one I'm going to call 12. And so I'm just going through and labeling these, and you could be off a little bit as you do that. So if you go through and disagree with something with me, we could be off by 1 or 2, but for the most part they're not too hard to read. So it looks like I have all those numbers. So when I add those up, 27 plus 11 plus 5 plus 12, I'm going to see that I have 81 total colleges listed here. So to find my center, remember your center is your median in this case. So when we're talking about the center of a histogram, it's our median, our middle number. So if I was to divide these by 2, 81 divided by 2 would be 40.5. So that means that my center occurs at the 41st value. That's where my center is. So to find that, I'm going to try and figure out where my 41st value is. So I have 27 plus 11, that makes 38. And then if I add 5, 38 to, so this bar right here has the values, the 39th value through the 43rd. And since 41 is what I'm looking for, my value, my center is in this bar right here. So between 4 and 6,000 is what I would say. I don't know exactly where my center is because that's a histogram. I wasn't given the data values. Now, if I was given a list of these colleges and their actual tuition and fees, I could find the center and I'd give an exact answer. But because I'm only given the histogram, I'm going to have to just go with this and give my answer from there. And then my shape. So if I wanted to, I'm going to erase this so I can look at my shape a little bit here. If I trace my shape, hopefully you notice that that tail's going to the right, so I'm going to call this right skewed. A lot of times when you're looking at money, things are right skewed. There's less of the more expensive and more of the cheap. So that's pretty common. My peak, so I'm looking for my highest part. My peak is happening right here. So I would list my peak as 0 to 2,000. And I'll make sure to label that dollars. And then my spread. So my spread is my minimum to my maximum. So my minimum value is 0. My maximum value is 20,000. So our spread is 0 to 20,000. And that's us describing that. You might want to make yourself a note here that your spread is min to max. That might help you. And maybe with your center, you'll reference this work up here so you know where that came from also. The next one then, you'll see we have percent of residents age 65 and over. So when I look at this one, I'm looking for some outliers, and it's number of states. So I'm assuming there's 50 states here. Let's add those numbers up. 1 plus 1 plus 3 plus 1 plus 8, 14, 13. Yep, we have 50 total states. So they have all of them listed. And they actually gave us our numbers here, which is going to help us when we have to do our center, right? So now, my outliers, do I have any that are really far away? Some people might think this is an outlier. It's actually not too far off. So I'm going to say this is not an outlier. If you, before we learn how to find outliers, if you would have listed this, I probably would count that right. But again, remember, we're going to learn that later. So for now, we're going to say there's no outliers. My center then, if there's 50 states, my center is going to happen between the 25th and 26th state, right? Because 50 divided by 2 is 25, but there's 25 below and 25 above, so it's between these two. Anytime you have an even number, you're going to have two that are your outlier, or two that are your center. So my center happens between the 25th and 26th state. So to find that, I'm going to say, okay, 1 plus 1 is 2, 5, 6, 14, 27. There's 27. So I go through my 27th state with that bar right there. So that's telling me that I have this right here is where my center is occurring. So that's between the 12th and 13th percent listed. So I'm going to say my center is between the 12th and 13th percent. And again, we don't have an exact value, but we know it occurs there. Then my shape, let me erase all this stuff so we can see the shape a little bit. I'm going to draw my line here for my shape. I'm going to describe this as pretty symmetric. Some people would maybe argue for left skewed just because of that number between 5 and 6, but really it's symmetric here. So that's the best answer for this. I don't think left skewed would be the best answer. And symmetric, remember, doesn't have to be perfect. You'll notice as we begin to describe these more, someone would call this fairly symmetric. That's how we would describe it. We kind of use different adjectives depending on how much symmetry is there. So this would be considered fairly symmetric. When it's asking for the peak, remember that's our highest bar. So for this one, that's happening right here where the 14 is. So it's between 13 and 14%. That's my peak. And my spread is my minimum to my maximum. So my lowest value here looks like it's at a 5, and my highest is happening right here at the 18. So I'm going to say my spread is 5 to 18%. So that's how we can be given a histogram. Now remember, we weren't given any data values, so we do that differently when we're just given the graph. And now we're given, the last problem we're going to do together is the 2008 payroll for Major League Baseball teams. And so if you look, obviously the Yankees are on top. That makes sense to us, right? And we expect the Twins to be pretty low. We're going to actually make a histogram. So to do that, I'm going to look at all of these values, and they give me the payroll here. And I'm going to try to use the graph you're given. So this is yours. I'm going to label the top Major League Baseball salaries. And then we're going to have to decide what we want to go by. Obviously with our data we're going to go in the millions, right? And it looks like my lowest value, so you're looking at your table now, my lowest value is the Florida Marlins, and they're at 21 million. My highest is the New York Yankees, and they're at 200 million. So I'm going to say that my x-axis here is going to be the salaries in millions. So salaries in millions. And then over here I'm going to have the number of teams that have that. So let's think how we want to group this. Obviously this is going to be a 0. Maybe if we go by, let's say, 20 million, let's see how that looks. So we'd have 20, 40, 60, 80, 100, 120, 140, 160, oops, I don't want to make those lines look like there. 180, 200, 220, is that my highest? And then, yep, that's as far as I need to go. So that looks like it fits pretty good. I could go by 30 million maybe, or 15 million. 15 million I'd have a little more spread out, but I'm not sure I'd fit. So 20 million seems like a good interval to go by. And that's a judgment call. You have to decide. Obviously, you hopefully realize that going by 50 million wouldn't be good, because I'd only have 4 sections. 10 million wouldn't fit on here, so you have to find a way to make an interval that's going to fit on the graph you're given and still show you that data. So now I'm going to have to go through and count how many teams belong in each section. So I'm going to the bottom of my list. The number of teams, oops, there we go. The number of teams that are in the 20 million category is just the Florida Marlins, right? So I have, in my 20, I have 1. So 0 to 20. 20 to 40, 40 to 60. So I'm going to make a table here and count how many teams before I make my histogram. going all the way through to 220, because that's what I numbered to, because of my biggest number was 209. And so now I'm going to count the teams. So now, let me erase this right here so we can use a different color. I had one team from 0 to 20. Then from 20 to 40, I've got 1, 2, 3, oh, sorry, 20 to 40. 20 to 40, I have 0 teams from 0 to 20. How about this? That makes more sense. Sorry. We have 0 teams from 0 to 20. Then from 20 to 40, I have just that one team, the Florida Marlins. And then from 40 to 60, I've got 1, 2, 3, 4, 5 teams. From 60 to 80, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 teams there. From 80 to 100, I have 1, 2, 3, 4. So we'll put a 4 there. From 100 to 120, I have 1, 2, 3, 4, 5, 6. So I have 6 teams. See how I'm going through this and making this list? And then from 120 to 140, I have 1, 2, 3, 4. And then you'll notice I have the only team I have left is the Yankees. They're at 209 million. So I have no teams in these categories here. And then I have the Yankees. So if I add this up, this should equal 30. That's how I could double check. So I've got 1 plus 4, so I have 5, and 10 is 15, plus 9 is 24, plus 6 is 30. So I've got the 30 teams here. I'm good to go as far as making my histogram. So now we actually draw our histogram from this label. So I had no teams from 0 to 20. From 0 to 40 I had 1. Oh, so we're going to label, sorry, let's label our side here. We'll go up by 1s, the number of teams in that category. And just to make sure, my highest one was a 9, so this is going to fit it perfect. I don't have to go by 2s. So if I'm making my histogram, that 20 to 40 was one team, and you're going to shade that in. And then I went to 5. I'm just going to draw my lines here. And then I go to 9. And then I go to 4 and 6. So 4, 6, 4 again. So I'm just matching my table that we just drew. Hopefully that's making sense to you. And then I color these in for my histogram. Yours will be shaded better than mine. And then I still need the Yankees here. I need this one from 200 to 220. And then I also like to, oftentimes I'll go through and label these up here so I don't have to think about it later, because I know they're going to ask me some questions about this probably. 6, 4, and 1. So there is my histogram. And now, if I was to list, let's just look at this. If we were to list the outliers, center, shape, peak, and spread. So if we're going to go ahead and do that, I know that's not in your notes, but let's just do it orally. What would you call the outlier? So I'm going to do that right here so we have room. You could do that in the same spot on your graph too. I would guess the Yankees are our outlier, right? So we're going to say we have one outlier. We'll call those the Yankees. And they're happening between 200 and 220 million. And then if I was going to talk about my center, I have a total of 15 teams here. So my center is occurring somewhere between, well, let's see. Or I'm sorry, I have a total of 30 teams here. So my center is occurring at 30 divided by 2, so it's my 15th and 16th team. Since these are listed in order, I can just go, I'm not going to use my histogram for this now because I have the data. I'm going to go back here and I'm going to look at my 15th and 16th team. Right here, I've got the Brewers and the Cleveland Indians. So to find my center, I'm going to take those two numbers, and I'm actually going to use the number, oops, wrong comma, sorry. And I'm going to add these two numbers together and divide by 2. So when I do that, that's going to give me my center, which ends up being 79,987,117. So if you're given the data, you use the data to find your center. If you're not, like we were in the previous two problems, we use our histogram. And then next would be the shape. How would you describe this shape? Let's see, let's just draw this in. I think we could say that it's slightly right skewed, and that's a term we use. So slightly right skewed. I'm not calling it right skewed because it's just a little bit. So slightly right skewed. And then the last thing we'd look at, oh sorry, we still have peak and spread. So my peak occurs definitely between, it's happening right here at the 9, isn't it? So between 60 and 80 million. That's my peak. And my spread, now I can actually find the exact spread. I can take the min minus the max. So I can take the Yankees of 209 million minus the Florida Marlins. Or if I use my histogram, I'd say the spread is 20 to 140 million. Now, notice what I just said here. My spread is 20 to 140 million. Why didn't I use the 220? The 220? Because my outlier is not counted in my spread. So I stopped right here. Let me circle it with a different color. Right there. I'm not counting my outlier. So that's what I wanted to point out about that. Hopefully that made sense to you. You are going to have a worksheet and an objective tomorrow, and please let me know if you have any questions on this.